Okay, so what if I told you that you could carve and shape the hardest metals on Earth, not with a drill or a laser, but with nothing more than electricity and salt water? I know, it sounds like something straight out of science fiction, right? But it's a very real and very powerful technology used in advanced manufacturing. Let's dive in to how we can shape metal without ever actually touching it.
You can really boil this whole family of processes down to one simple idea: reverse electroplating. Now, you've probably heard of electroplating. That's where you use electricity to add a thin layer of metal, like chrome, onto an object. Well, we're about to look at 4 amazing industrial processes that do the exact opposite. They use electricity to take metal away, and with unbelievable precision. The science behind it all is surprisingly elegant. So picture a piece of metal. That's our workpiece. We pass a direct current through a stream of salt water that's flowing right over it. That electrical current gives the surface atoms of the metal a little nudge, turning them into ions. And then, the flowing water just washes them away. That's it. No cutting, no friction, just a perfectly controlled atom-by-atom dissolution.
All right, so first up is the big one, the heavy lifter of the group: electrochemical machining, or ECM. This is the real powerhouse technique for removing large amounts of material, and it's where the magic of non-contact shaping truly shines.
And this is the really wild part. The tool and the part you're working on, they never physically touch. Not once. There's this tiny, constantly flowing gap of salt water between them, and that's where all the action happens. This single principle is what gives ECM all of its superpowers.
So how does this actually happen? Well, it's a super slick 3-step dance. First, you apply the power, sending a current through the electrolyte. Second, that energy instantly ionizes the metal atoms on the surface of your part. And third, a high-pressure jet of that same electrolyte flushes those ions away before they can stick to the tool. It's just this continuous, incredibly efficient cycle of dissolve and remove. And the benefits here are just mind-blowing. Because the tool never touches the part, you get zero tool wear. I mean, think about that for a second. No more sharpening, no more replacing expensive cutting tools, and since there's no friction, there's no heat damage or mechanical stress put on the part, which is absolutely crucial for high-performance components. This means you can machine basically any conductive material, even the super hard alloys that would just shred conventional tools.
So where do you actually see something like this in the real world? Well, a jet engine turbine blade is the perfect example. It's made from an incredibly tough alloy built to survive insane temperatures. To do that, it needs these complex, snake-like cooling channels on the inside, something that's totally impossible to make with a normal drill. ECM is the only way to sculpt those intricate shapes, which lets the engine run hotter, and that directly translates into more power and better fuel efficiency.
Okay, so ECM is our powerhouse, our master of bulk removal. But what happens when you need, a finer touch, when you need more precision and a perfect surface finish? Well, that's when we bring in a little bit of mechanical force to create 2 really powerful hybrid processes.
Let's put them side by side. On one hand, you've got electrochemical honing, or ECH. Its whole job is to create perfectly smooth internal surfaces, like the inside of a cylinder. It uses electricity for the heavy lifting and then brings in conventional abrasive stones to give it that final, super precise finish. On the other hand, you have electrochemical grinding, or ECG, which is all about precision grinding on really tough material.
Now check this out, because this is what makes ECGs so special. A whopping 90% of the material is removed by the electrical action alone. Only about 10% is actually handled by the abrasive grinding wheel. What that means is the wheel is barely even touching the part. It's more like a gentle wipe than a forceful grind. And that means you get almost no heat and no stress.
And you can see just how specialized these are when you look at what they're used for. ECG is perfect for getting that flawless internal finish you need in things like gun barrels. It's critical for accuracy. Meanwhile, ECG is the go-to for creating ultra-sharp surgical needles that cause less damage and help you heal faster. It can even grind super thin-walled tubes that would just get crushed by a traditional grinder.
So we've covered bulk shaping and precision finishing, but there's one last absolutely crucial step in manufacturing. We need to talk about the specialist, the process that comes in to clean everything up: electrochemical deburring.
You know how when you cut paper, you sometimes get that slightly fuzzy edge? Well, pretty much any time you cut, drill, or mill metal, you get the same thing, but on a much more serious level. You're left with these tiny, sharp, unwanted ridges called burrs. On a simple part, they might just be an annoyance, but inside a high-performance engine, they can be catastrophic.
This is where ECD gets seriously clever. It's just a basic law of physics that electricity naturally concentrates at sharp points. And what's a burr? It's just a tiny sharp point. So the process is basically self-targeting. The current automatically zeroes in on the burr and dissolves it away in seconds, leaving the rest of the part completely untouched. It's like surgical precision, but it's automatic.
And get this, the speed is just insane. We're talking about a full cycle time of often less than 30 seconds. A really complex part that has dozens of hard-to-reach edges can be perfectly deburred and ready to go in less time than it takes to make a cup of coffee. That's efficiency on a whole other level.
You see it used in some of the most critical components imaginable. Think about all those intersecting oil passages deep inside an engine block, or the complex pathways in a hydraulic valve. A tiny stray burr in any of those could break off and completely destroy the system. ECD makes sure every single edge is perfect every single time.
So, when you put it all together, what do we have? We've looked at 4 distinct but clearly related processes. And really, the best way to think about them is as a complete toolkit, where you just have to pick the right tool for the specific job you're trying to do.
So let's lay it all out in a simple cheat sheet. ECM is your power tool, your go-to for bulk shaping, doing 100% of the work with electricity. Then you've got ECH and ECG. Those are your hybrid finishing tools, combining electricity with a light mechanical touch for surface geometry and precision grinding. And finally, you have ECD, your specialized finishing tool, using focused electricity to get that perfect, clean edge.
When you step back and look at it, this isn't just a set of manufacturing methods. It's a fundamental shift in how we can think about shaping materials. It opens the door to designs and levels of performance that were literally impossible before. Which, of course, leaves us with one last big thought. With a toolkit this powerful, with technology that can shape the hardest metals with just salt water and electricity, what are the limits to what we can create next?